We want to find the exact components of the vector using the angle shown below. But notice how for this example there's no angle shown, but if we assume the initial point of this vector is at the origin on the coordinate plane, it'll be helpful to sketch the x and y axes. So this would be the x-axis, and this would be the y-axis. Notice how we're also given the magnitude of vector b is 39, and since this vector lies along the negative x-axis, if it has the initial point at the origin of the point 0, 0, if the magnitude is 39, the terminal point of this vector, this point here, would have to be negative 39, 0, which is all we need in order to find the component form of vector b. Vector b would have an x component of negative 39 and a y component of 0. But let's also take a look at the definition given here below. If a vector has a known magnitude and makes an angle theta with the positive x-axis, then we can find the component form of the vector where the x component would be the magnitude times cosine theta and the y component would be the magnitude times sine theta. So for this vector, probably the most obvious angle for theta would be the angle with the initial side here and the terminal side here, which should be 180 degrees. Of course, we could use any other coterminal angle, but this is probably the most obvious angle. We already know the components of vector b, but let's see if we can find them using this definition here. Let's write this as vector b would be equal to the magnitude of vector b times a unit vector with an x component of cosine theta and a y component of sine theta. Well, we know the magnitude is equal to 39. We also know a possible angle for theta would be 180 degrees. So we could have cosine 180 degrees here, comma sine 180 degrees. Now there are several ways to find these trig function values. If we look at the unit circle, notice how 180 degrees would intersect the circle at this point here, and on the unit circle x equals cosine theta and y equals sine theta. So cosine 180 degrees is equal to negative 1, and sine 180 degrees is equal to 0. We can also find these trig function values by looking at the graph of sine and cosine on the coordinate plane. Cosine at 180 degrees, or cosine pi, would be here with a function value of negative 1, and sine at 180 degrees, or sine pi, would be here with a function value of 0. So whichever way we approach this, cosine 180 degrees is negative 1, and sine 180 degrees is 0. So we'd have 39 times the unit vector negative 1, comma 0. Performing the scalar multiplication gives us the same result, an x component of negative 39 and a y component of 0. I hope you found this helpful.